All right, we're moved on to the last day of factoring, the hardest core day of factoring. All right, so to begin with, do you see what these two terms have in common? This term and this term. They have something in common, just as much as if I said 2x plus 12. What do they both have in common? They both have a 2 in them, right? Kind of like that. What do both of these terms have in common? Yes, sir? The x plus 2. So I can put an x plus 2 out in front, and after I factored that out, these are gone, and you see I have 6x plus 2 left. All right, we're going to be trying this method one more time. The guy that came in and subbed for me the other day showed you this method, and I'm going to make sure you get how you could have done this problem using that method. All right, so let's say this type of a problem. We have 6x squared, and then plus 19x plus 15. And this is a tough one to do with guess and check. It really is. So if you want to guess and check your way on the test, you'll be able to do that. But I want to give you a better way. 6 times 15. It might take you a second. 6 times 15. What is it? 90. Good. The question becomes, what multiplies to 90 and adds to 19? What multiplies to 90 and adds to 19? 10 and 9? Do you get that? Okay. So here's how it works. You don't say 19x in the middle anymore. You say 10x and 9x. All I did was replace the middle here with this. Do you get that 10x plus 9x is 19x? I didn't do anything different. I just rearranged this thing. Yes, sir? Are there other ways to make a 90? Sure. Okay, 7 times 12. Does 7 times 12 make 90? Because it multiplies to 90 and it adds to 19. Yes, sir? 10x plus 9x makes 19x. Nope. I think you're thinking wrong. If I did this, I couldn't even add them together. They have to both have an x on them to be able to add them together. Okay, so 10x plus 9x makes 19x. All right, we good so far? All I did was multiply the end two numbers together, and then I can ask a little question. What multiplies to this and adds to that? You know what this comes from? It comes from back when the problems were really easy, like x squared plus 2x plus 1. And you say, what multiplies to 1 and adds to 2? A 1 and a 1. And you knew that that must be in the answer then. Well, we can't do that on this kind of a problem because this lead coefficient number here is different than 1. And so we can't just say what multiplies to this and adds to that. But what we can do is say what multiplies to this and adds to that. Okay. So now I've got this set up. That part right there at the front, what comes out of both of those? 2 does. 2x does. And what's left? 3x, because this times this makes that, okay? 3x plus 5. And now what happens on the other side? What comes out of both of these? 3 does. What's left? And now do you see how I'm all set up? Just like the problem I gave you before, what goes into both of these? That does. Okay, now, I know that's pretty intense, but it's a way that'll always work if you are having trouble with your guess and check. I want you to try just one like that. Okay, see if you can handle this one. All right, now try it the new way I just showed you. What do these make? 6x. So if you go 3x squared, what multiplies to 6x and adds to 7x? What multiplies to a 6 and adds to a 7? 6 and a 1. So you write down the first and the last part, and then you just change this 7x to a 6x plus a 1x. That's the exact same thing as 7x. Now you factor this part and you factor that part, and you're going to have it done. Okay, so I go 3x goes into both of these, and I get x plus 2. And then over here, if there's nothing that comes out of them, you just say 1 comes out of them. And I have x plus 2. And then x plus 2 must be in the answer. And then the other part must be 3x plus 1. Could you get it by guess and check? Yeah, you could have. But just trying to show you a different way. Okay, usually what happens after something like this is 4 or 5 of you are now empowered with this new way, and you're like, oh, cool, that works for me. I like that way. And then the rest of you are like, yeah, I'm just going to go back to the way I was doing it before. And that's okay, because at least you've had your mind stretched a little bit, and now you can go back to factoring it the old way if you want. Yes, sir? Yeah, if you don't have the 1 there, what would happen is, at the end, if there was no 1 here, you'd be like, okay, so x plus 2 goes into both of them, and then what do I put? 3x? You know what I mean? I need this to have 2 parts. So yeah, I need that 1 there. So I need to say 3x plus 1 when I'm done, because that 1 right there was important. Okay, but again, guess and check works. It really does. All right, so let's now see, here's an answer that a kid has. And when you multiply it out, it works. Why would it be marked wrong? Because there's a negative in it. You can't have a negative in the front of an x. You can have a minus in between 2 things, but you cannot have a negative on one of the x's. So then how can I'm going to multiply this out first and go negative x squared, outside, inside makes plus x, and the last makes 2. So how could the kid have done it correctly then? When you had this problem right here, you have to start by getting rid of the negative, which means you have to factor out negative 1. Do it, everybody. And then factor it from there. Don't try to skip any steps. Once you factor out the negative 1, you got to write this next part. X squared minus x minus 2. Then x, and then guess and check is just fine on this. What multiplies to negative 2 but adds to negative 1? Negative 2 and positive 1 multiplies to negative 2, and it adds to negative 1. There we go. There's the final answer, and that one's okay. Remember what it looked like before? The negative in the front of it? Can't have a negative inside like this. Not allowed. Okay, next one. Something's wrong with this answer. Even though it multiplies out and gives you the right thing, why could it be not right? Yes, ma'am. What part's wrong? The 2x minus 2 part. What could be wrong with that? There's a 2 in both of them. So this answer would have been marked wrong. But if the kid had done this, factored out the 2 out of both of those, and then put it like this, x minus 1. That's right. Except really we should put the 2 in the very front of the whole thing. But other than that, I don't think I would mark it wrong just because the 2's in the middle. But it'd be better if it was in front. All right. So then let's see what the original problem would have been. Original problem would have been 2x squared, and then the outside and the inside makes negative 2, negative minus 8x plus 6. That would have been the original problem. And what would have been smart to do right at the beginning of that problem to keep that from happening? If you'd just done something really quick and easy at the beginning, it would have made life so much better. Factor out the 2. Everybody do this and then billboard it to me. Factor it all the way. Yes, the 2 comes out is the first part, but then finish it. Let me pause for a second while you finish these. Okay. Tell me how you did that. Guy in the front row in the blue, I know your name, but I'm not going to say it in the video. Perfect. Now what? Perfect. All right, raise your hand if you had that one right. All right, let's see if I can blow your mind for a second. Ignore this 2 for just a minute. Watch what I can do. 3 times the 1 makes 3. What multiplies to 3 and adds to negative 4? A minus 3 and a minus 1. Now, do you get that this and this are exactly equal to each other? And now watch what can happen. Factor both parts. X comes out, x minus 3. Well, negative 1 has to come out. X minus 3. Look at that. This is in common here and here. So x minus 3, x minus 1. Maybe we should teach you that way right from the start. But then don't forget the 2 that comes down. Okay. It's just an option, and some of you are going to get good enough at it that that'll become your thing. And then factoring's done a lot between now and calculus. Oh, you're going to factor all the time. That's why one of the reasons we spend so much time on this is because it's so important. We need you to be really good at factoring. Okay, next thing, I'm going to talk to you about a couple things that are on a little quiz that you're about to take. You're going to take a homework quiz. And let me show you what the quiz kind of looks like so that you can know which one to take. We've already taken the one that has a check mark next to it, 0 product property one. We're going to now take the one called vertex to general form and ZPP. And I don't want you to start it right now because I want you to just get a little bit of chance to see some review before we take it. And then tomorrow, you're going to be taking this one called factoring. Tomorrow's your review day, and then the quiz on this stuff is on Wednesday. All right, so be ready for your quiz on factoring on Wednesday. All right, so I guess the vertex to general form and ZPP, here's some like prep for it. Vertex to general, this is in vertex form. No, it's not. I already screwed it up. Okay, shut your iPads. These are quick answer ones. What's the vertex? 3, 5. The one on the inside is the opposite. The one on the outside stays the same. 3, 5. Okay. What's the y-intercept? Nope. I got a few people. I knew I would. The y-intercept is not that number that sits way off to the right. The y-intercept is where, fill in this blank. Y-intercept is where what? X equals 0. So you put a 0 right here, and you get negative 3 squared, which is 9 plus 5 is 14 is the y-intercept. Okay, the y-intercept, now I got the y-intercept and I got the vertex. Could I graph it from that? Well, I can get close. The vertex is 3, 5. Dot right there, and the y-intercept was at 14. It's up like there, and at least I know it's going to look like that then. Okay, could I have gotten some other points by going over 1 and up 1, over 2 and up 4? Yeah, you need 5 distinct points. All right, next thought. Vertex to general form. If this was in vertex form, how could I get it to general form? Generally, you just, what? Multiply it out. Generally, just multiply this out. So what would happen first? That would have to get squared first. And it's not this squared and that squared. You can't do that. You go this way. And then you'll remember that you do first outside, inside, last, and the answer's got 3 parts. And then you add 5 to it when you're all done. Okay, that's how you get general form. Next part. If you're going to do a ZPP question, zero product property, they're usually set up like this. And most people know how to do this part and say, oh, the answer's 5 for this one, and then they get confused over here. And they think it must be like -3, because some people get in this bad habit of thinking, oh, it's always the opposite of this number, so this one must be -3. No. How do you really do these? You really are setting this up as x minus 5 equals 0, x equals 5. And over here, 2x plus 3 equals 0, and then you solve the little equation out. And you get a fraction, and it's negative. And don't just try to guess and go, I think it's going to be 2/3. It's not. Okay, so let's do this one quick. How do I start? Minus 3, 2x equals -3. Now what? X equals -3/2 and 5. Those are my 2 answers using what's called the zero product property. Because this times product, that equals 0, and so therefore either this is 0, and that's what would make that happen, or that part has to be 0, and that's what would make that happen. So there's my 2 answers. Okay, so there's a little review for you. Got a little quiz right now. Go ahead and take the one called vertex to general and ZPP. No, it's in the anchor one. Looks like this. Vertex to general and ZPP. When you're done with that, the worksheet for today is factoring worksheet C. C as in cow. And yes, you have to do all of them. But you should be so good at factoring by now that you should just kind of fly through it. I'm hoping this will be an easy assignment, even though it's kind of medium size. All right, that's all I got for the recording for today.